Welcome everyone. Welcome to part 2 of OPC UA Inside Out webinar series. We're very happy to see old as well as new faces today. We actually have a house like the first with attendees from various countries and time zones. A special hello to all our listeners in US. Most of you have asked for a recorded version of this webinar as it is late night or early morning there right now. My name is Anand Taparia. I take care of marketing here at Utthunga together with several of my teammates. In the first webinar of this OPC UA Inside Out series, we had covered the foundational and technical aspects of OPC UA. In today's webinar titled Embedded and Constrained Devices, we will share the importance of OPC UA in embedded and low footprint devices. Why do you even care for OPC UA in your embedded devices? We will then help you understand the various considerations and decisions that you will have to take to implement OPC UA in your embedded devices. Jishan, you can mute yourself. Next slide, Chatrapathi. Okay, before we get started, just a quick overview of Utthunga. We are an industrial software and hardware services company partnering closely with leading OEMs in the industrial world to build products and solutions from concept all the way through the life cycle of the product. With over 500 engineers, we offer services in application development, embedded services, IoT, and verification and validation. Our services are targeted to OEMs and end industries in process, factory, power domains. Next slide, please. Thank you. We hear this adage a lot lately. Data is the new oil. Even though overused, data has tremendous power. There is a huge amount of raw data locked in sensors and devices and equipment. At Utthunga, industrial connectivity is the foundation of who we are as a company. Using standard protocols like Modbus, Ethernet IP, HART, Profibus, even MT, or some very legacy and obscure protocols, or by adding the digital layer to dumb and non-digital devices, we specialize in unlocking the data in the field level and making it available upwards to the various systems. Our association with various industry standards that you see on the screen here, and importantly the OPC Foundation, is rooted in our commitment to industrial connectivity. With that, I would like to introduce you to our speaker for today. Next slide, please. Thank you. Chatrapathi. Chatrapathi is the Director of Embedded here at Utthunga. He is an active member in OPC Foundation Working Group and has contributed in creating use cases for OPC PubSub on small footprint devices. Chatrapathi has a solid understanding of OPC UA on devices companion specification. Having executed several projects with OPC UA nano profile, served high performance demands, such with heterogeneous communication requirements for protocols like HART, Ethernet IP, 2850. He good knowledge on field devices, the NAMO standard, and semantic ID. Chatrapathi has also worked on different open source and commercially available OPC UA stacks. Just a few final housekeeping points before I hand it over to Chatrapathi. This webinar is for 60 minutes. We will keep the last 10 minutes for questions from you. Please send in your questions using the Q&A icon on the left side of your screen. The slides of this presentation and a link to the video of this webinar will be shared with everyone post the webinar. Please click on the full screen icon again on the left-hand side of your screen to get a good view of the slides. Before I hand over to Chatrapathi, just a very quick poll, if everybody could please participate. You can see the poll on your screen right now. Okay, I would pause the poll at this moment. Seems like majority of the people here in our attendees are coming from the product development interest in OPC UA, and very few from testing. And good to see the end user community present here as well. With that, I would now like to hand over to Chatrapathi to take us through the session today. Over to you, Chatrapathi.
Thank you, Anand. Good morning, good evening, everyone. So before we get into our technical agenda, let's just look at why having embedded OPC in the low footprint and constrained devices is important and what advantages it brings. So the first one is plug and play. Usually so if you look at a PLC and when you are configuring your PLC, so most of the time is spent on creating different tags based on the heterogeneous devices and protocols that the PLC is connected to and controlling, and based on the memory maps created in the PLC. So with OPC directly running on the devices, the mapping and the tags are already there. You just need to select the tags which you are interested in to monitor from your OPC UA client application. So that just reduces the training efforts, infrastructure efforts, and the IT support efforts, and so on. And also, OPC UA OPC information models are being standardized by different working groups, different protocol working groups, so that more and more devices, when they implement embedded OPC on their devices, they follow a standard information model. So with that coming in place, you can very easily replace a specific device from vendor A using a different device from vendor B in the same running operational environment with a very minimal effort and with a very less downtime, because both the devices follow the exact same OPC information model standardized. So some examples for such specific information models are PAD and then the PLC Open, which is meant for all the PLCs. The next one is ease of integration. So there are several cases where you need to have vertical as well as horizontal integrations at the PLC level or even in the down layer, where the devices need to communicate with each other. And so one such example for vertical integration is energy monitoring and management applications. So usually from the layer below to the PLCs, only the process variables and the process related data only is acquired. But with OPC in place, you can leave the process data be acquisition aside, and separately in parallel, you can acquire what is the energy consumption of each and every device from bottommost layer till the upper layer, and your entire system is aware of how much energy it is being consumed. This is just one example of vertical integration. So all such possibilities are suddenly real. And then cross-functional integration. So for example, your factory building is running on a separate building automation system, and then the factory itself is on the separate factory automation system. So with OPC in devices in place, the integration between these two, for example, if the building's heating system fails or building's fire alarm goes off, then accordingly you can take some safety controls on the factory. So such cross-functional integration and such cross-functional applications are certainly possible with embedded OPC in devices. And data accessibility. Again, this brings out the same important point where the data to the upper layers, I mean, in the industrial automation pyramid from layer 3 and above, the accessibility of data is only whatever is exposed by the PLC. Nothing more is exposed. But with once top to bottom OPC is supported in all the layers, then from any layer, any piece of data can be accessed without jumping through the hoops. Also, because it is OPC, you won't be simply getting only the value of a particular variable. So you will also be getting at what time that specific value was there in that variable and what were the engineering units. So you will get some context of that particular value. So it's not data anymore. It becomes information for you. And the last point is security. So most of the industrial automation protocols either not secure, or you will have to do something special, something additional part of the spec to make it secure. So for example, if you have any PC with a simple Modbus master program running in it, you can connect to the network and you can send commands to the Modbus devices and they'll happily accept it. So that's a very huge security risk. So OPC brings in security for the data in terms of authentication, authorization, encryption, everything. So a few more advantages. So having embedded OPC in devices brings down configuration efforts and configuration training costs and need for several PCs, because usually PCs with OPC servers installed are used in between to gather data from the down layer and even from the PLCs. And also when you have PC on the factory floor or in the processing plant, those PCs requires again additional IT support. And then you don't have to train your customers on different configuration tools or different troubleshooting methods, and in some cases these are somewhat proprietary. So you will be as a vendor, you will be spending less time in supporting the customer, because this is just plug and play kind of thing, and you just select the tags which needs to be monitored. And you will have to go through different set of protocol converters and drivers to gather data from different heterogeneous devices. Now once OPC is there, then there is no need for such protocol drivers. So otherwise the PC software where you have OPC is installed, it will be having Ethernet IP driver to talk to an Ethernet IP device, get the data, and then consolidate it and expose it via OPC UA server. So now the device itself will have the OPC UA, so that eliminates the need for protocol converters and drivers. And because of the ease of plug and play, overall the downtime will be much less. So this is just a simple use case. So this specific network monitoring device is one of it's a product which sits in a Profinet network. It analyzes the traffic and it runs very sophisticated algorithms on the collected data in terms of statistical analysis, in terms of prediction, and in terms of detecting any anomalies in the data in the network, whether any specific device is malfunctioning, whether any cable is not performing at optimal level. So all such algorithms are executed and all the such data is collected. So to have access to that data, there is an additional Ethernet port, and using any PC you need to connect and access the web page from that to see the data. So, but once the entire rest of the network has gone into OPC UA mode, and when they started getting gathering data using an OPC UA client cloud-based application and trying to make sense out of the data, this particular network monitoring product was a little bit of bottleneck. So that's when, as part of one of our projects, we have embedded OPC UA server on the network monitor. Now, with that, the advantages is in the network monitor, OPC UA client, when it connects, it can see how many devices are connected and what are the current state of each device and how they are behaving, everything. Plus, whatever the intelligent data that has been gathered and calculated and statistically analyzed, and all the outcomes and predictions of all those sophisticated algorithms is suddenly available openly to the cloud. So before OPC, somebody needs to look at the data and manually take a decision or take a corrective action. Now the OPC UA server client application that runs in the cloud itself makes those corrective actions and just notifies the end user. So as per today's agenda, so now that you have a fair understanding of what kind of advantages having OPC UA in embedded devices brings, when you want to start and have an implementation, so there are different steps you need to go through and different decisions you need to make at each step. So this goes in both ways. Maybe you are trying to develop a brand new device, or you already have a device and you have scope for to allow some of the memory and processing power on the device to be utilized by an application. So you can think of embedding OPC UA server into your existing device. So provided your existing device have an Ethernet port and TCP stack and so on. Okay. So so when you are going through these slides and when you are hearing it out, so keep both the aspects in mind. Either you may be trying to develop a brand new device, or you may be trying to embed OPC UA server or OPC UA application into your existing device. So while defining requirements, you need to consider the functional requirements, meaning whether your device is going to be a client or server, or whether it needs a discovery mechanism, or whether it should be answering to a discovery mechanism. Do you need historization of the data, and to what level you need your device to be configurable, and so on. And you need to consider defining performance requirements, and in a very simple terms, it is just number of tags plus their corresponding update rate, meaning at least 1000 tags with update rates of 100 milliseconds, something like that. And you can have the different sets of such combinations based on as the number of tags become more, the update rate, meaning the time, also becomes more. Also, you can consider at least how many number of connections you should maintain, meaning once you have OPC UA server in your device or client in your device, how many servers it should connect to, or how many clients it should allow to connect. So that becomes so based on the use case of your device, what is the maximum possible and usable scenario. From that perspective, you need to define number of connections, and per connection the number of channels, and in each channel how many sessions, parallel sessions, how many subscriptions there can be in each subscription, how many monitored items, meaning tags, you can add. So all such things you need to define. So in many cases, whatever the device you are trying to create may have a an existing any of the industrial automation protocol as well, and you may be still using OPC for few of the tags and few of the pieces of information which are not critical for the processing part of it, but you may want to use it for additional applications. So example is the energy monitoring application. So how much energy consumed by the device, that variable may not be used by the actual process part of it. So it is possible for you to have Modbus and then OPC or Ethernet IP and then OPC in parallel running on the device. So you need to consider as an industrial automation device what should be its performance in terms of the other protocols as well. And based on this, again, hardware requirements in terms of all the different certifications and all the CE certifications and intrinsic safety certifications and so on, and security, whether you want to have security of OPC UA enabled on the device or not. If yes, how are you going to manage the certificates? So you want to keep it very easy and simple, or you want to have a very tight control over the entire certificate management. So in all those aspects you can define, and whether you need any specific hardware certifications or not, and also whether you want to get your device certified by the OPC UA Foundation's lab. So this is a very important step, because getting your device tested and certified by the foundation lab, it makes very comfortable for the end users to look at it and buy it, because it guarantees interoperability in most of the cases, unless you have some specific custom implementation with respect to any of the objects defined in your information model. Other than that, most of the cases it guarantees the interoperability. So that's where certification comes into picture. So when you look at different types of OPC UA applications, the broad classification is it can be a server or client and server. So there are simple server examples where a small sensor which simply exposes few variables like temperature and its units, something like that. And it can be a very complex device where hundreds of parameters are exposed, and there are different ways to configure, and you can have different methods which can be invoked from the client to do the configuration of the device and so on. And there are PLCs with few thousands of parameters, and then how do you configure the PLC to fetch the data from the connected devices and different methods associated with it. And then a standalone OPC UA server to aggregate from several field devices. This is a standard example where you have PC with OPC UA server software installed on it, and you are configuring to connect to different PLCs and get the data. So right side you can see a simple architecture of one such device where you have OPC UA stack and address space, and you will have an integration interface to a PLC memory block and PLC's own logic application, and any OPC UA client can connect and have access to this address space and the methods that are running here. And a simple client example can be a client which just connects to the device, collects the data, and then pushes to any network database or cloud infrastructure or to an analytical platform and so on. And there can be a small edge analytics executing on the collected data, and then that data being exposed as again as an OPC UA data that becomes a simple client server example as well. So, and in some cases you can connect to a different OPC UA devices and collect and aggregate the entire data and then expose the data. So this collection of data can be from OPC UA devices or even from the field devices. So that is one example of where client and server both will be running on the device. So apart from this, there can be a simple publisher or subscriber, publisher and subscriber. So those three combinations are also possible. And you would choose the publisher subscriber or publisher plus subscriber based on the kind of cycle times, the kind of use cases that you are interested in to use the OPC UA for. So development approaches, there are at a very broad perspective, there are three things. You can do a full product development and maintenance, including develop your own hardware, develop your own stack and application. In most of the cases, the stack is actually purchased from a technology provider, and in most of the in many other cases, the entire implementation is taken support from a technology provider. So what can technology providers provide you when you need something to do with OPC and embedded devices? Starting from support in defining requirements, and if you are trying to do it on an existing product, they can help you in feasibility study whether the existing device and whatever the current configuration of the hardware alongside already existing firmware already running, how much scope is there for OPC UA to be enabled in the product, whether it is possible or not. If possible, with what features it can run. So in evaluating such scenarios, technology providers can help you. Hardware design, prototyping, and supporting in different hardware related certifications. And then hardwares. So you can buy a hardware itself from the technology provider. There are some providers who provide integrated boards, and you can design your product around the board, or you can buy a fully packed industrial PC and just put your client and IoT application, which can be a gateway application and so on. And they can help you with the stack development, or if you want to buy out a commercial available stack, they can help you in making the decision of picking the right stack based on your requirements, porting of stack to your specific hardware platform, and designing the information modeling, which is very important, and the OPC application development itself using that specific stack, and integrating the stack with the existing device application. And different configuration applications and monitoring applications on PC based can be developed, and CTT testing, and you can get support in obtaining the certification from the OPC Foundation testing labs. So with respect to hardware, if you are designing your own hardware from the scratch, then there are different microcontrollers and microprocessors for which OPC UA has already ported, and they have some different chip vendors have different reference boards and developer kits which you can consider for the development part of it. And reference designs also will help you in coming up with your own hardware design as well. All the Gerber files and the design files, everything are also available freely on the chip vendors websites. So what you need to consider is whether the specific chip will be satisfying your processing and memory requirements based on whatever the performance requirements you have defined, whether it can support multiple protocols. For example, can it allow OPC UA to run alongside any of the industrial Ethernet protocol? And you need to consider the component cost and development cost, because this is where your cost will be so high. Stack licensing. So even though these reference designs are available and you buy the chip, still you need to purchase a license from the stack vendor in most of the cases separately, which you need to use for your development. And usually these stack licenses are per product version based, meaning for product line based. And there are some already designed single board computers, meaning boards, embedded boards with such MCUs and MPUs on them, designed with Ethernet ports and all. So with that also, most of the considerations what you need to look for is same, but with one additional constraint. When whatever your product design, you need to work around this particular embedded board, so you will not have as much freedom as you should be if you compare it against the first option. And then there are some Ethernet embedded switches which you can consider for your hardware component. They also, again, you need to check whether they are multiple protocols are supported or not, and whether it has a TSN support, because moving forward, TSN and OPC PubSub is becoming very popular at lower level devices. And hardware designs, and whether this particular Ethernet switch is compatible with rest of the components that you are picking for your hardware design, and so on, you need to look about. And there are some industrial computers. These are like these are useful for a gateway type of products where both sides, I mean, one side it is anyway OPC UA, the other side also is any of the industrial Ethernet based protocol. So you can run your own software inside them, but hardware wise you will not have any options. So you need to look for whether it can be white labeled as per your company branding and that type of aspects, because there's nothing much for you to worry about there. Then there are software considerations. You need to see which OS you need to use for the implementation, or how do you design the information model, what to do for the stack, and how do you develop an OPC application, and then the device application. So we'll look into each of these aspects. So for operating system, you have different FreeRTOS, TIRTOS, RT Linux, and no OS, directly bare metal. So all these options are available. So based on your performance requirements, you can choose which one to go. And then the performance. So for the, if you're choosing any of these RTOS, that RTOS to execute that RTOS itself will have some requirements, like how much memory it requires to run and how much CPU percentage it needs to be in a running condition. So in addition to that, whatever is available, apart from that, that's what is available for your OPC server, stack, and application. And then you need to do porting, and you need to do the development of the application, and debugging and maintenance efforts. All these things you need to consider. So a FreeRTOS or RT Linux application may be a little bit easier to develop and debug, considering against a bare metal application subjected to all this depends on what kind of in-house capabilities you have, or what kind of technology providers ecosystem you have, who are you partnering with, whether they have all such capabilities. So based on this, you can make the decision. And then information model. So you can choose any of the existing information models based on different organizations. So OPC Foundation itself published many of these information models, and there are other organizations also who are working on standardizing the information models, VDMA and all. So like I already given the example of PLC Open, that is one information model which is specifically for PLCs. So similarly, for different device profiles, different devices, there are different types of information models that are standardized. And you can customize any of these information models with additional fields and additional aspects to meet your specific requirements, or you can come up with your own information model. But designing an information model that requires skills and good understanding of OPC UA. And the important aspect of the software is stack. So you can develop your own stack. Of course, that is the least popular option, but you will have control over your implementation. If you are looking to implement only a very limited set of specific features of OPC UA for your specific device requirement, so that you have total control on the implementation, then only then you can go for this. That will be a very special situation where you want to choose this option. This requires expert skills on OPC specification at specification level and protocol level, not at the user level. The second option can be you can buy it from a technology provider. The advantages are these stacks are proven, tested, ported to different platforms. Different products are already available in the market with these stacks running on them. Even when you buy the stack, still you will have to have some skills to use the stack and develop and maintain the application on top of it. And then updates, bug fixes, maintenance, all that will be provided by the stack vendor. And then you can use open source stack. But still you will have to worry about porting it to a specific target platform, and also it requires skills. If you find any issues, or if you are facing any roadblocks or any of that, it's very hard to get a active and timely support if you choose an open source stack. So there are some technology providers who would still use an open source stack for your product, and they will provide you the maintenance or support that you require. So that is also available. And while choosing a stack, you need to consider the following. So whether your functional requirements, whatever you are defined for your product, whether those are all implemented in the stack. Because in OPC, some features are optional, some features are mandatory. So in the stack, whether everything that you defined for your product is implemented or not, you need to check for. And whether the stack can meet your performance requirements or not, and how much CPU percentage is required by the stack for a simple specific application. And code memory, runtime memory usage separately, you need to look at it. Also performance benchmarks based on number of tags and update rates, how much memory it is required, how much CPU is required, all such results and data sheets you need to look at. And then how easy is it to develop an application on top of that stack, whether interfaces are clearly defined, or you need to study and there is a huge learning curve involved or not. So such aspects you need to worry about if you are using your own developers who doesn't have any experience with OPC before. And then how easily you can integrate your device application with OPC stack. So from that perspective also, you need to think about it and look at the interfaces. And flexibility to choose different features of the stack, meaning so the stack may come with full features, but for your product, whatever is required, only those features can you enable and exclude the remaining features. How easy is it to do? So if you comment a function and you're expecting everything else to work, is it designed such a way, or at the compile time itself you can eliminate a specific thing and use it? So that aspect also you need to evaluate. Documentation and any reference applications are available. So if possible, take those reference applications, try it out and see if that works out for you. Then this is profile selection and customization. So there are different profiles standardized by OPC Foundation. So nano embedded device, micro embedded device, embedded device and standard. These are server profiles, and these are other profiles also: client, publisher, subscriber, GDS, which is a global discovery service server, transport, and security profiles as well. So we are going to talk about the server profiles because of the time constraint. So nano embedded device profile, it is suitable for very small devices with sensors with few variables and configurable engineering units. And then the key requirements are: it should support a single session and support server and server capability subject. This is defined. Server and server capability objects are defined in the OPC UA information model. And it should allow authentication with username and password, and basic read and write services to the address space. Then micro embedded device. This is also suitable for smaller device with few more variables and few. And then here the key requirements is, in addition to nano profile, there should be at least 2 sessions, and the subscription comes into picture in micro embedded profile. In the nano profile, there's no subscription. So here at least 1 subscription per session and 2 monitored items per subscription, at least that much. If you need to support, then you can choose a nano embedded device profile. And then the embedded device profile, between micro embedded and embedded, the major important addition is security, and also the number of monitored items and number of subscriptions are increased. In addition to security, there is a method calls, which is also an additional. So for example, if you want to reset the device, resetting a device has to be done through a method call. So such features are allowed with method calls. Otherwise, it is just you are writing and reading variables, and you're not doing anything else. So with method calls, you can do some configurations. You can reset the device, or you can put it into some self-test mode. So all such things are possible. So those features are added as part of embedded device profile. Standard device profile is a full-fledged server with most of the OPC UA features enabled, suitable for industrial computers, PLCs, and then where you need to handle thousands of tags. And if you feel that any of these profiles are not specifically suiting to your requirements, you can pick any of the profile, or you can pick individual features to come up with your own customized profile. So some example customizations I have given here. Nano profile plus transport security, because nano doesn't have security, or nano with a complete full-fledged security with encryption and everything. And diagnostic information is part of standard profile, but even though your device is of micro profile, you may still want to add diagnostic information to your device. So all such customizations you can do while choosing your device profile. And the last item is security. So if you want to implement security in your devices, you need to consider 2 things. One is OPC UA security, and with respect to OPC UA security, most of these OPC UA stacks, they need additional support from any of the security stacks, like the Embed TLS stack or OpenSSL stack. So you need to port those stacks. And of course, the memory requirements and runtime memory requirements, CPU utilization, everything increases drastically the moment you bring in security in, because each and every piece of information that goes out of the device is being encrypted, and whatever the information that comes in is being decrypted. So you need to see if you have enough juice in your device to support this. And then you need to define a clear workflow for the certificate handling. So apart from the OPC UA security, there is a second aspect of device security. I mean, how secure is your device? So for example, secure boot. So this makes sure that nobody is simply sending their own firmware update to your device. And encrypting data. So any configuration files, settings, whatever you are storing on the device, you should be encrypting that. And you can prefer to have certificate-based authentication instead of username and password, whoever are allowed to configure the device. Or you can implement a simple list-based IP and port rules in your TCP/IP stack, where if you don't get connection request from a list of IP addresses, you can reject those requests, all such simple things. And also you can keep a log of failed attempts like wrong password, certificate mismatches, all such cases. And based on if this goes beyond a threshold, you can raise an event, or you can send you can set a status flag or something like that. And if your device is having multiple physical interfaces, like even the JTAG is still open, or even there are multiple Ethernet ports, but some of them are currently may not be being used by the end user. So in such cases, you should provide an option for the end user to disable such ports which are not being used. So with that, the technical aspects of this presentation is stopped. We'll look at the question and answers. Okay, so this question is from Santosh. The question is, what is the difference PADIM and OPC information modeling? Does PADIM is laid out over OPC information modeling? Okay, so in the presentation, I was talking about different working groups. They are defining a specific information model for specific protocol or specific types of devices. And like PLC Open is for the PLCs. So any PLC who wants to implement a PLC Open information model, that is standard. So similarly, PADIM is for process automation device information model. So if you are creating a process automation device, for example, a flow meter, then on the flow meter, you can have an OPC UA server whose information model is defined as per the PADIM specification. So in other words, PADIM, it is one standardized information model from the OPC UA Foundation and Fieldcom group. I hope that answers your question. So how can we improve the performance of OPC UA server monitored item more than 1 lakh tags, even doing subscription in batches? Okay, so there is no short answer or simple answer for this. So first of all, you need to look at the constraints. The constraints can be anywhere from anywhere from the PC hardware where it is running, or the design of the stack, whoever is designed the stack, how efficiently or how they have designed it. And also the OPC UA stacks support a specific service set which is called register nodes. So if you have a set of tags which you are trying to access very frequently, and those tags, if you register with the server, then the server tries to reduce the accessing time for those particular tags and give it in a efficient manner. So this is defined in the spec. If those servers implementing register service allows you to register more tags, you can use that. So yeah, basically identifying bottleneck, that's what is important. So it can be even network bandwidth, or it can be the processing power alongside your OPC server on that system. There could be something else running on it, or it can be the design of the stack itself. So you need to find out where is your bottleneck. So can we send the command to OPC server to take the action, onto device from cloud. Okay, so this question is not clear to me. Let me understand based on how I interpret this question. So you're asking, you want to control a specific device from an OPC UA server. Okay, so that doesn't sound right. So usually OPC UA client connects to the server, and the client is the one which sends any write operations to the OPC UA server or method calls to OPC UA server. OPC UA server merely supposed to transfer those write requests to the underlying device or execute a command based on that method call from that server to the underlying device. So if you have a OPC UA client connected to the server which supports method calls, and those method calls have specific underlying device driver related commands are linked to those method calls, then yes, you can do it. Does UA embedded device support PubSub as well as client server architecture? Okay. See, it depends again on the use case. Do you want it to have both client server and PubSub architecture in your device? Yes, because for PubSub you would need a UDP packet transmission as a transport layer, and for the client server you can have TCP. So from the specification perspective, yes, but from the use case perspective, do you need it to be? And that's what you need to consider. Is security not a basic requirement for OPC UA? So this is again depends on your protocol, your profile selection. So for some profiles, it is not mandatory. At the protocol level, you will still call it as a secure channel, but you will select the security policy as none. So that means it will not be encrypted, and you can see the packet format freely on the Wireshark if you capture non-security policy data on Wireshark. OPC UA communication uses which media, means Ethernet or serial. So it is based on Ethernet. So nowadays it is even they are coming up with specific profiles for TSN network. So even on gigabit Ethernet and with TSN network also the OPC UA works. Can you please throw more light on information modeling skills? Okay. Yeah, so information modeling by itself requires one part of a seminar, and it can't be squeezed into this specific part which we are talking about today. We'll definitely consider information modeling as a topic for our further seminars in this series based on how popular the demand is. On one of the first slides, you mentioned that configuration was simple with OPC UA. Can you expand on the topic, please? So, okay, so a simple example is this is it's not just about OPC UA, it is against the traditional configuration versus OPC UA unembedded configuration. So, for example, your PLC is implemented and your PLC have an OPC UA server. Now, whatever the tags that you need to monitor, you don't have to create a tags, you don't have to configure the tags, and you don't have to map the tags to the PLC's memory blocks. So directly you will use an OPC UA client, connect to the PLC, and all the tags are already created in the PLC's information model. You will just select and drag and drop the tags which you want to subscribe, which you want to monitor. So that way there is a very little or no need for the tag configuration or tag mapping. The moment the OPC server is available on the PLC. If that specific PLC follows PLC open information model, then the client already knows the information model. Even without browsing, without even selecting, it can just connect and then start reading the data. So I hope that clears up for you.
Chatrapathi, could we make this the last question, if possible, given the time?
Yeah.
You can take one more if it's quick.
Yeah, this is the last one.
Okay.
Device security is different than OPC security. Is it necessary to purchase separate stack or service? Okay. So device security is definitely different than OPC security. OPC security only talks about whatever is within the OPC scope. So device security is a different aspect of it, how you can make your device secure. There is no specific stack or service for that. I mean, you will have to find a consulting service for with respect to device security, who can be there with your device product development team from start to end, giving the considerations and the corresponding consultation for making your device secure. So in any unanswered questions, we will respond back or email. Anand, that's possible, right?
Yeah, absolutely.
So with that, I'd like to thank all of you for your time and listening to me. Please take over.
Yeah, quickly. Great. Thank you everyone for the amazing questions, and I'm sure Chatrapathi must have enjoyed answering those questions. As he mentioned, we will definitely get to you by an email on the questions which we were not able to answer. Just before we wrap up, just a couple more minutes, a quick poll that I wanted to get your input on. Just a second. So it's on your screen now. If you could please share your responses. I'll close the poll in about 15-20 seconds. Okay, I will close it. And so we have of course, as expected, we have a varied mix of people, and for the ones who definitely are looking for support, we would be very happy to get in touch with you, and feel free to reach us as well. Just before I wrap up, I would like to just cover up what's coming up in terms of the OPC UA Inside Out webinar calendar. The next one is on May 28th. It covers the role of OPC UA in edge devices. Edge devices sit above the field and embedded devices in the ISN95 pyramid. We, of course, covered the embedded devices today. The fourth one is on tunneler, to cover the integration of OPC DA, which is the classic OPC, and UA products. The next one after that is on the role of OPC UA in cloud connectivity and IIoT. With near infinite, in quotes, compute power and storage available in the cloud, the ton of data that is being generated in a typical plant floor can be run through advanced visualization and analytic engines in the cloud. So this could be an interesting webinar as well. In the last webinar of the series, we would cover the challenges of connectivity in brownfield projects and the importance of implementing OPC UA ground up in greenfield projects. So I request you all to block your calendars. We will surely share the registration links with you. If you want us to cover a specific topic or topics, please email us at marketing@utthunga.com. Hope to see you all. Stay indoors. Thank you very much.